你好，老师。
Hello,
How are you, 老师
hello everyone. Can you hear my voice and see my PowerPoint?
Yes,
Yes,
Lakshmi,
Laushi, we can hear
Okay.
your voice and
Hello everyone. I'm glad to be your teacher and friend from now on. I'm 罗琦。I'm 罗琦。This this semester I will teach you the core permission measurements and control system. This is my telephone number and email. Sometimes when I'm busy at work, I may not be able to answer the phone in time. Whether it is about study or life, welcome to send me emails to communicate. Okay.
Laushi, can you provide your WeChat account, WeChat ID?
Uh-huh.
Wishing, Laushi, WeChat.
All class have a WeChat group. You can take it in me. Okay, let's start the course on precision measurements and the control system. First, we need run robots. First, we need to learn about the course on measurements and control. What is measurements? Measurement is codification of attributes of objects or events, which can be used to compare with other objects or events. We are all familiar with the basic international units. Measurements most commonly use the international system of unit as a accumulation framework. The basic quantity, time, ledger, mass, electroconnects, temperature, amount of substance, thermal intensity. The basic unit, second, meter, kilometer, ampere, calorie, mole, candela. The simple SM, KGA, K, or CD. These basic unit we all are familiar with these basic units. Let's record the measurement of variance. Lasers. The measurement resolution of the most common ruler is 1 millimeter. And the measurement resolution of the vinegar caliper is 0.05 millimeter. And the resolution of micrometer is 0.01 millimeter. And the grating ruler is the resolution of grating ruler is up to 1.2 micrometer. The measurement resolution last interferometer is 1 nanometer. Measurement is very important to a system or a machine. For example, in your car, we can see there are lots of sensors that measure various variables. It is these measuring sensors that interpret the normal and the safety drive of the car. You can see the camera sensor, stream talker, different neural context, angle sensor, a position sensor. Sorry. Both of Chinese master and one of China the greatest scientific Qian he said, the key technology of the new technology revolution is information technology. Information technology is composed of measurements technology, compute technology, and communication technology. Measurement technology is the key and the foundation. Scientific developments and breakthroughs are often led by breakthroughs in testing, adjustments, and technical methods. The fact that about quality of the Nobel Prizes in physics and chemistry have been awarded for innovations in testing methods and adjustments shows that the importance of testing adjustments in scientific research. The invention of optical macroscopes in the searching center enable people to observe cells with the help of microscopes, which greatly promoted the development of biological science. And the emergency of electron microscopes in the 1930s brought home observed capability into microscopes worlds, which in turn promoted the development of biological science, electronic science, and material science. So these effects shows the importance of test investments in scientific research. The major level, the famous lecturer chemistry level said, measurement is essential to science. Or measurements exist in every aspect of our lives. For example, buying, sharing, and exchanging of goods, and performing scientific experiments, preparing medicine and treating patients, and prepared foods, and global understanding of the quality of substance. Okay. What is control? What is control? Control is steering a collaborative system of a state variables towards a desired goal. This is the schematic of classical mechanical device, the steam engine. And we all know the steam engine is a great invention, whose appearance was caused the industrial revolution in the 18th century. It remains the world's most important primer until the early 13th century, when it gradually gave way to the international combustion engine and steam turbines. One question: how does the steam engine control the speed? This is the control diagram of the steam engine. Let's focus first. I will look at the video.
here or entry. So I think and then we're going to looking at now the middle or in the middle spindle, and in the lower section we have sleeve, the outside, two round objective eyeballs, then two linkages and two arms. Now what's going to happen is as the centrifugal governor cellophane, so as the whole thing spins, you're going to see the sleeve, the lower piece, moving up and down. See it moves up and down, it's going to linkage or right here, and that is going to then open this, change the position of this valve there. So talked you through how it works, but I probably should have showed you a bit easier. So that's spinning, and it's spinning quite slowly. Now it's increased in speed, so the spindle has moved up slightly. That up again, I can show you again. Slowly, increase in speed, the fly balls move out, and now they're at the furthest position. Notice that the fly balls now are extended further out from the sleeve than they were originally. So what's happening is an engine, for example, will be rotating at a certain speed, let's say 100 RPM, and it's going to rotate the horizontal shaft at 100 RPM, assuming the horizontal shaft is geared directly. So RPM on the horizontal shaft, and we're going to transfer 100 RPM through the bevel gear here and to the centrifugal governor. 100 RPM. There we go. So notice the arms are not particularly far away from the sleeve, but at the increased speed, let's increase now to 200 RPM, the arms have been further away against the motor, further away. Now to speed it up even further, see the arms now are really quite far from the spindle. Increase in speed, the weights of fly balls are going to be further and further away from the central stem. And as they do this, they are going to put up this like sleeve section here. You can see the linkages only allow them to travel so far. And as they move out the weights, they're going to pull the central sleeve. So got three different speeds there: 100 RPM, 200 RPM, 300 RPM. Know that at decent speed, the balls will get thrown further and further upwards until they reach their maximum limit. So all we're doing really is taking the speed of the engine and we're representing that by this governor. But the governor being connected to this lever type arrangement is jumping from there to there, and it's jumping down, then coming on there to there, and finally see the whole shaft comes through the wall, through the pipe, and we have here a valve. So we've got here a valve, and what we do, if I zoom out again, I'll try and get the governor into the picture at the same time to see the valve. So the governor is slowed down now. We're at 200 RPM. This valve now is only a halfway open. So that's something we call one. So again, now pretty much fully open. We can see the governor arms have come down again. Now further, now it's slowed down. So let's run through that again. Okay, change position. Now it's throttled. It's running at 200 RPM, and now it's running at 300. Let's imagine that's very, very fast, and the valve here is now closed. So why would we set up that centrifugal governor like that? See doing? Well, the reason we set it up like that, imagine that in this pipe here is a lot of steam. So a bit of steam or coming along here, and it gets stopped by valve. Valve is throttle, it's not open. You know it's 200 RPM, and the steam can flow through again. So what's going to happen now? It's flowing through. But maybe the engine or whatever it is, steam that's coming through there has not taken effect yet. So the engine has not accelerated yet. Imagine you've got a steam engine. So keep playing it. Now it's fully open. If we're allowing all of that steam to pass through the valve to go to a steam engine, then the steam engine should start to accelerate again. And that's exactly what happens. But see, now it's accelerated. And now it is operating at maximum speed or near maximum speed. So we want to close the steam inlet valve. And using this arrangement, we can control that steam compared to the steam engine. And then if we control the amount of steam going to the steam engine, control the speed of the engine. And this is the very simple way to control the speed of the engine. It means we don't have to have somebody there constantly closing. And it does it all automatically. Essentially what centrifugal governor does. Again, now we're fully open, we want the engine to increase the speed. The engine's increased, so we close the valve bit. Now it's going too fast, and we've completely closed the valve. That's it. And it will toggle between these three different positions. You can set them up so they're accurate, so the tolerances are minor. For example, imagine you wanted it to operate between 1300 RPM and 1500 RPM. Then you can set the valve up the governor accordingly. Design, but very simple. The Victorians really didn't have certain mechanical engineering. And personally, I find it quite wonderful machine.
Okay. Let's go back to this diagram. Steam into the wall. To drive the angle. To drive the angle modulation. Then through a critical link angle mechanical to drive the rotation of the shaft and then through the bed drive to the bevel general rotation. Drive to the bevel general rotation. The bevel general movements. The ball, the flying ball, constantly outwards and upwards movements. And the ball movements of drive these parts up and down. And then through the link and mechanism to adjust the size of the wall to achieve the speed control. The CNC computes nomenclature control system for machine tool are equipped with very precise measurements and control systems to produce a variety of complex and delicate products. Measurements and control are two tasks for mankind to understand and transform the world, and the measurements and control system is a tool and means for mankind to achieve these two tests. Products related to measurements and control affects 30 and 36% of economy with a volume of 4% of industrial GDP. In the 1950s, parametric instruments was invented. The measurement range of the parametric signal is 20.67 to 103.13 35 kilopascal. We can see the parametric control the parametric control the parametric actors by regulating the volume burst and the parametric signal from transmitter is feedback to the parametric controller, forming a closed loop control. The all progress forming a closed loop control. Measurements and control adjustment is in a closed state unable to communicate information with the outside world. In the 1930s, electro unit combined instruments appeared. The measurement range is 40 to 20 mm. As the figure shows, is a generalized control room of thermal power plants. It can simultaneously. We can see it can achieve similar operations and control in real time according to multiple points information and observe the states of the production set in the control room. In the 1970s, computer measurement of the control system with the rapid and development of science and technology, the computer measurement and control system was invented in the 1970s. The degree of automation and the intelligence of the measurement and the control system is significantly enhanced with high precision, high performance, and multiple function. Computer technology brings new features and new functions to the measurements and the control system. First, auto zero. First, auto zero. Auto zero function. Auto zero function which automatically zero the output automatic zero function which automatically zero the output value of the sensor before each sampling, and that thus so greatly reduce the error caused by drift changes of measurement and the control system. So-called automatic range switch, which can change the measurement range and the control range according to the size of measured value and the control value, and improve the resolution where essentially the measurements and the control range. The multi-point rate measurement and control, which can quickly measurements and control a variety of different parameters. The digital filtering. The digital filtering function, the use of computer software to process the measurement data. Can suppress various interface and plus single. Auto error correction. This function can correct the nonlinearity of sensors and the controls. And the compute technology brings a new feature and a new function. The data processing, this function can statistical analysis, short search, spectrum analysis, and on. the complex control function, such as PID control, adaptive control, fuzzy control, and then the multimedia, such as sound, light, and voice. Communication function, which can express it internal interface data transmission. Self-diagnosed function, fault alarm displays the fault location or possible cause of the fault. This typical instruct the typical instruction of the computer measurements on the control system is shown in this flow chart. We can see measurements control objects and to the sensor. Then send the analog inputs to the macro computer. Then paired Hamil machine interface, then achieve the operator. The measurements and control objects to the actor and analog approach Microsoft macro computer, and this is objects to sensor is reduce digital inputs, send it to macro computer, then to communicate the interface to other macro computer. One question: how we run the computer measurement and the control system? We need to run computer measurement and the control system from these 5 aspects. The first is to run Arduino-based system control. We can make use for the simulation platform, the Tinker CAD.com. The Tinker CAD is a free web app for lectures and coding. We can use this online platform for system simulation. Online web of software in which all model looks similar to the real thing, so that it is easy to make an impression during use, while providing a good balance to physical construction and to physical construction. However, at present, the soft supports only a limited number of components and does not support the function of shelf-based connects. It is expected to be improved in the future. The second is project drive. The third is hands-on. Four is process assessments. And the last is creative learning. How we learn? I will teach you to master measurement and system control based on Arduino by learning the 15 projects. I will learn the 15 project to study the to master the computer measurements and the control system. Okay. Attention please. Attention please. Important statement about the scoring. About the scoring. Attendance recording is 10%. 10%. Each class is 1% and 10 times. And the increments is 56%. We are attention please. We complete the assignment of each lesson during the class. For each assignment, first showing others that each project is completed through screen sharing and give some comments. 4%. The second, use your documentation to track the projects you have completed for each project. At least keep the recording of sales scores, coding, and use comments. The final presentation is worth 34% of user scores. The final presentation is worth 34 of user scores. The 23% depends on the creativity, complexity, and completeness of design, and order implementation of user slides. 11% depends on the design materials, documents, background, design plans, source codes, program in float chat form. conclusions, and project fairs, demonstration, animation, and slides. Our course teaching is week 6 to 30, and the last 2 week, 40 and 13 weeks. The order of the student use presentation is according to use student ID. Okay.
Yes, 老师。
What? What's wrong?
No, 老师, I just appreciate the slide.
Oh, sorry. Okay, let's have a break. Okay, let's have a rest. See you later.
Okay, 老师。
Okay, let's continue.
OK，老师。
All right. Which one of you is the class monitor? Which student? Which,
Me 老师
are you the class monitor?
yeah about 3 or 4
I'm in the class WeChat group,
okay
and you can add me on WeChat.
okay 老师
You will be responsible for the attendance of each class.
老师 we are 3 monitors there's another monitor who is responsible for that but don't worry 老师 don't worry it's okay it's always been that
Laushi, who will send you the attendance? The another
Okay.
monitor. No problem.
All students' assignments head into the class monitor, who will correct them and send them to me.
okay 老师
The class monitor need to send me the students' attendance and segments before every Wednesday.
alright
Okay. We have the class monitor use student number is what is use student number?
55 last number is 55
55.
and yeah this one but
Okay.
the one in school there's another monitor last number is 老师
Actually, my neighbor was like that.
Okay.
老师 there's another monitor last number is 666
6.
Yeah, up, 老师 a little bit up in the middle. No. In the last number is 66. Yeah, around there. No, 老师 lower. Yeah, 66. Yeah, and 老师 there's another monitor with last number 30. There are 3 monitors. No, 30. No, 老师 no.
30老师30。
30还有一个人30，我们3个人。
Oh, okay.
不是，这个不是啊。对，30。up 老师 up，对，我们3个人。
Okay.
我在学校，我
We
在
can
学
communicate.
校
Okay. We can communicate with the WeChat.
可
Okay.
以。好，
Okay.
老师 you just sent a link in WeChat group. I can't open it. I sent a screenshot in meeting chat box. Can you check it?
Okay.
It showed 4040 Laoshi. Doesn't open the link.
Doesn't the link? Okay, let's continue. In this introduction to the Arduino basic kits projects, you will learn about the Arduino platform, how to set up use kits, and how to interact with the circuit simulator. These are the tools you need to create the successful Arduino projects. And first of all, we will learn how to use the Arduino platform for circuit control from these five aspects in turn. The first is welcome to Arduino. Second part is pass in the case. Third, the third step is program the Arduino in symmetrical environments. And the fourth step is program the Arduino in kits. And the fifth step is build a simple circuits in the simulator environment. Welcome to Arduino. Become extraordinary. Most of us learn the program to engineers because we think coding and electronics are complicated and difficult. But they can actually be fun and exciting activities. Thanks to Arduino, designs, artists, hobbyists, and students of all ages are learning to create things that rent up, move, and respond to people, animals, plants, and the rest of the world. Over the years, Arduino has been used as the brain-in source of creative projects. A worldwide community of Macs has gathered around this open source platform, moving from personal computing to personal fabrication, and contributing to a new world of participation, compilation, and sharing. Now let's check out the 10 best Arduino projects. Oh, sorry, sorry. Okay. What about these projects? Are they very cool?
Yes,
what
sir.
are your favorite Arduino projects?
Mhm.
About the 10 Arduino projects, any students have any idea want to share? Of these are top 10 Arduino projects we are seeing. And there are plenty of other very cool Arduino DIY collections. Arduino is open and simple. If you start with the assumption that making digital technologies is simple and accessible, you can learn how to do it too. Cellular electronics and codes can become creative tools that anyone can use, like brushes and pens. paint. We will walk you through the fundamentals in a hands-on way. With creative projects you build by learning. Once you are mastered the basics, you have a palette of software and circuits that you can use to create something beautiful and making someone smile with what you invent. Arduino makes it easy to program tiny compute-scaled microcontrollers, which are the chips that make objects interactive. As shown, there are some primitive microcontrollers. The ultimate AVI, the VR HX Mega. Actually make 3 to 8p and so on. We are sorted by those of microcontrollers every day. They are embedded in tabs. Thermostats, tools, remote controls, microwave ovens, and even some tooth solutions. The D1 specific task, and if you hardly notice them, which is often the case, it's because they're doing it well. They have been programmed to see and control activity using sensors and actuators. Sensors listen to the physical world. The convince energy that you give off when you press buttons or when you use arms or sheds into electro signal. Buttons and clocks are sensors that you touch with your fingers, but there are many other kinds of sensors. So sensors are important components in system control. And the picture shows various sensors, such as the color sensor, temperature sensor, rain sensor, gas sensor, water flow sensor, and so on. These sensors are very important in system control. Similarly, the actuators are a dispensable part of the system control. Actuators take action in the physical world. They convert electrical energy back into physical energy, like lights and heart and movement. Correct. They are the actuator. There are three main type the three main types of drive of actors. First type is parametric control wheel. The second is electromotor, and the three type is hydraulic motor. Microcontrollers listen to sense and talk to actuators. They decide what to do best based on a program that you write. And therefore, microcontrollers plays a key role in the system control. Physical electrical paths commonly used in Arduino-based system control are resistance, single lump button, battery, battery, button, drive motor, breadboard, Arduino control board, and this display and on, and so on. The components provided by the simulation platform are resistor, LED, battery, vibration motor, DC motor, and so on. The push button, breadboard small, Arduino, and so on. Let's take a look at the modulars in the Arduino control board. The control board. First parts. All connector. All connects. This is how you power use Arduino when it is not plugged into USB ports or port. It can accept voltage between 7 to 12 volts. You do not need to do anything with this in the search simulator. You do need to do anything with this in the circuit simulator. The board is always powered. On the USB ports, this is the USB ports. Used for powering user Arduino or no. Uploading user sketches. You use Arduino. And for communicating with user Arduino sketch. Again, you do not need to worry about the port in the simulator. The board automatically communicate with program. Or reset button. This is the reset button. Resist the Archimbanger microcontroller. This button is not really functional in the simulator, but on a physical board you might have to use it if use board isn't acting the way you expect. The DX-RX LED. These LEDs indicate the communication between use Arduino and use computer. Expect them to work rapid during sketch uploading and while the board communicates with the computer. These lights are used for debugging. The TX is receive. TX is receive. The TX is transmits. TX is transmits, and the RX is receive. RX receive. We can use the two lights to debug. These parts, digital pins. This part is digital pins. Interpreted binary dates on off from inputs component like a switch. You will learn that digital pins are used with digital arrays, digital lights, and analog lights. Analog lights works only on the pins with the pulse-width modulations. This part is an analog pins. Interpret a range of signals from input components. Use these pins with analog read. And these parts, three parts. Pin 13 LED. The only outputs built into use Arduino Uno. Besides pin handling for the breaking LED sketch in the next lesson. This LED is very used for debugging. Let's continue to see this part. 18 microcontroller. This part is a blend of use Arduino Uno. It's the blend of use Arduino Uno. And this part is power LED. indicates that use Arduino is receive port. This light is used for debug. This light is also used for debugging. These three parts, JND and the 5 pins, use these pins to plug with 5 volts pole and 0 ground to 0 volt ground to use circuits. You already created the ground and the 5 volts pins to the blade board with lens. Okay, it's time for a break.
Okay,
Let's have a
Rashid.
rest. Okay.
Class is over. Hello.
No, it's break time now.
What, bro?
Break time now.
Break time.
Yeah.
Okay, everyone, let's go back to class.
Yes, sir.
Okay. Some students said cannot. Some students said cannot enter the simulation platform. This simulation website is not very stable. You can when it's something wrong, you can choose the login again. And sometimes you ever need to use the VPN. When you use the VPN, the simulation website is very stable. So you can use the VPN when you use the simulation platform. No, I'm not using the VPN, but I can log into the simulation platform. Sometimes it's really not very stable. So you want to make sure the simulation platform very stable. You can use the VPN. Okay, let's continue the class. Continue the class. Programming the Arduino in simulator environments. After understanding the composition of the Arduino control board, let's learn how to program the Arduino in the simulation environment. The code editor is where you write, upload, and run scripts. There are few additional buttons in here, which are described below. To download codes, use this button. To create a file you can import into the Arduino IDE on your computer. This will be helpful if you start a project in the simulator. Then want to transfer it to the physical Arduino board. So you can use this button to download the code. The libraries. This is of a code that expands the fraction of a gram. In this case of Arduino libraries, the Azure enable communication with a particular piece of hardware. All are used for modifying data. A serial monitor. Serial monitor is a tool built into the Arduino IDE that allows you to send and receive data between the compute and the Arduino. Use the code editors in simulator. First, we should collect personal codes. Let me have okay. We run the simulator experiments for the four three steps. First is run the demo. Two is the two step is changing the breaking length. Three step is detecting a problem. Okay. Okay. First, we should collect X personal codes. You can choose the email registration. And how to register, I will not go into detail. First, you can log in and collect the design and select secured operation. Secures. And then collect collect at the new circuit. Collect a new circuit. Then enter the circuit construction interface. Boots. Put a Arduino board, you can edit the code. You can see, you can edit the code. The code editor, you can choose the block and the text way. Editor model, we choose the text. We choose the text. Okay. Let's go back to the this is the codes. This is the download codes. This is the libraries. This is the editor model. This is the serial monitors. We can we can edit the code in this text. Okay, let's go back to our plot. Next, we'll learn about the program Arduino in the real physical environment. The first step is to install Arduino IDE. Install Arduino IDE using the installation adjustment for use operating system. At the second, we can use the website to download the Arduino IDE. The second step, navigate to the LED blend example sketch. A sketch is the Arduino program. It's located on the, you can see, file. Then choose the examples master blank. Second step is next choose the serial port use Arduino is collected from tools the reports manner. The next step is unload the Arduino, sketch the board. Here. And the last step, Arduino will take action. You should see a bar indicating the progress of the upload near the lower left corner of the Arduino IDE, and the lights label TX and RX on the Arduino board will be blinking. If the upload is successful, the IDE will display the messenger. So when you see the lights label text next on the Arduino board will be blank. You have successful programmed the Arduino to blank the onboard LED. You're almost done rolling the basic of the Arduino platform and circuit editor. Also, the Arduino IDE on use computer and the code editor in the simulator look at least difference. You should see a lot of similarities in how the two are used. Okay, let's see the Arduino IDE. This is the Arduino IDE. When you connect the physical Arduino, we are use the Arduino IDE. We can see here example, basic, and blank. We can click the upload and upload the Arduino sketch to the board. Upload. Okay. Let's go back to ET. Okay, we learn about the programming the Arduino in simulation environment and the physical environment. Let's learn about how to build a simple circuits in the simulator. The example sketch that you run only black LED on the Arduino board itself. Things will get a lot more exciting when you are started. Adding components to the blade board. In the circuit, the circuit is schematic. A button, is used to collect and break a connection that allows connected to flow through the LEDs. We can see a button is used to collect and break a connection that allows the connected to flow through the LED and the resistor. Let's do another breaking LED sampling, but this time simulator LED will be connected to pin 13 on the Arduino Uno. There are 3 steps to build a simple circuit. First step, start out by connecting the power and the ground layers of the breadboard to the 5 volts and ground pins of the Arduino Uno. This step will be done at the beginning of all of your projects. On the second step, you will add a LED and the resistor to the breadboard and connect them to pin 13 on the Arduino. The last step, try staying the simulation. You will see that 2 LEDs are now bleeding, that one on the Arduino as well as the LED on the breadboard. Okay. Let's make the simulation. Okay. Now we are program a real Arduino in the simulator. Now, we build our first simple circuit. This is use first interacting circuit use a button. Oh, let's see. Use a button. Or resistance and LED. You are going to use the Arduino in this project, Arduino, but only as the source of power. One plug into a USB ports. Or 9 watts battery. So Arduino will provide 5 watts between its 5 pin. In the circuit, you can see in the circuit schematic button used to collect and black connections that are not collected to flow through the LED and the register. First, connecting pole. Connecting pole. If you are using a physical case, unplug any button or USB cable connected to the board. The Arduino should not be receive power where you are building the circuit. In this step, you will provide the power to the board. Voltage varies from the Arduino. The runway are the 4 horizontal rows of the sockets at the top and the bottom at the top and the bottom of the blend. Red for power, black for ground. Blue use circuit. The red for power, black for ground. So first, we should connect a wire between the 5 pin on the Arduino and the read power on the board. Collect we can collects where between the 5 pin on the Arduino and the read power rail on the board. Color will treat the reads. And the next connects ground on the Arduino. Ground on the Arduino to the blackboard to the black ground rail with the way. With the black the ground on the Arduino to the black globe, with the black globe way. The next step, we can know the color. I use the drop-down menu, can choose different color. The second step will add a resistor and wires. You will finish the circuit in this step. In this step, use 220 ohm resistor and less. You will set the resistor value. We add a resistor. Now you will set the resistor value by highlighting the resistor and using the drop-down menu. we can see we can change the resistance. You will see the resistance value by hitting the resistor and using the drop down menu. You can renew the resistor color code in the project spaceship in the interface. We choose the In fact, you will need this code to identify the resistors that come in use kits, since they are not labeled with number. We change to 20 to 220. Okay. So it continue. First step, we drag our resistor into the work plane from the components mentor. Then change its value to 220. And use the drop menu. Use the drop method. Then use the register to collect the left element of button with ground level on the board. Place drag a button into the work plane. Drag a LED into the work plane. Collected or vary from the right template of the button to the template of the LED. And collect out when from the right temperature of the LED to the 5 watts level on the breadboard. The color should set to the red. So the glass has four step. First step, plug resistor into the workplace from the components menu. The second is to use the resistor to collect the left button. Then collect the wire from the right terminal of the button to the LED. Then collect wire or run from the right terminal of the LED. To the 5 watts level on the blackboard. Okay. Once the circuit is complete, you can try simulating it. Click the Start Simulation button in this way. We can see the results of the simulation. We can see this left this outside RX and TXX notes lights was a problem. Okay. We can see the simulation. Try pressing the button. When you press the button, you should see the LED lights. When you press the button, the LED lights were up. You can see when I press the button, you can see the LED lights. We can see the LED lights up. It's a simple, very simple circuit. Let's make a review. First we drag a Arduino board. Then we add a below the board. Then collect a value, the 5-volt pin on the Arduino. 5 pin on the Arduino. And read the power on the board. Breaks ground on the Arduino to the black ground, and to the black ground array with the array. Then drag a register, change its value to 220. Then add a button and the LED. We can connect the wire from the right button to the LED. And collect wire from the right corner of the LED to the 5 volts relay on the breadboard. Okay. Let's stop the simulation. After successful simulation, in the physical environments with real operation, will also expect the same effects. Okay. we can see the another make another simulator. Okay. Okay, we see another simple table. When click the simulation, we can see the lights is work. When we change the delay 10. You can see. We can see lights. It changed. Okay. Okay. Let's use the simulation platform to complete the segments. There are two segments. The first one is try to use the P12 to black the LED. In 12 to black the LED. And the second is try to set the black rates at twice a second. And twice a second.
老师, what is the deadline to submit the assignment?
The delay is we can see it here. The delay time you can adjust.
Laushi, when we need to submit the assignment, the deadline we asked for.
Here. We can complete the segments of each information during the class. So you can make the segments. Next time, you can make the segments. Any question can ask me, okay? And the deadline is next Wednesday. Next Wednesday.
Okay, Laushi.
Okay,
Next
Laushi. Thank you,
Wednesday.
Laushi.
The class monitor, our students' segments are into the class monitor, who will collect them and send them to me.
Okay, Laushi.
Class monitor needed to send me the students' attendance and the segments before every Wednesday. Now you can make the segments of the class. Okay.
Laushi, my apps is not working.
It's
Also, can you please send the PPT to our group?
I just did a demo. For build a simple circuit. The pin is 5 watts. You can see. Segments. Try to use pin 12 to black the LED. Try to see the black rate at 12 seconds. Continue to use. Uno boards, like blade board. Watts. Front. Chest.
Laushi, after finishing this, how we will save the file?
What?
After finishing the project, how we will save the file?
Right. What? we can to set the black lights at twice a second. We can see here. You can see the lights changed. Black lights changed. So the black lights we are adjust by change the delay time. Change the delay time. I explain the code. Void sets up. First is the input LED button outputs. First, we are initial the need to initial the digital pin at the output. We can you can
老师，老师 you have written delay 50. So 50 means it will blink 50 times per second. Yes, yes.
50 milliseconds.
Oh, 50 milliseconds.
Yeah,
Close.
milliseconds. The digital lights. Digital lights is turn the LED on. Digital lights main turn the LED on. The high is the voltage low. So this sentence, digital lights, it turn the LED on. LED button. The high is the voltage low. The delay delay 1000 milliseconds. The digital lights button low mean turn the LED off by making the voltage low. This sentence also is waiting for 1000 milliseconds. So the assignments is very simple. First, try to use pin 12 to black the LED. The two is try to set the black rate at 12 seconds. Use the pin 12. Any students finish the segment simulation?
Now,
Yeah.
Laoshi, this software doesn't work. It showed that it's 404 error. How can we do this?
Maybe you can use the VPN because the internet this software, the online software is very sometimes it's really not stable. Maybe you can turn it off and re-log in. If any students completed the segment, you can share use screen and give some comments. On the segment recording, the segment simulation recording, a segment simulation recording can be done with the OBS, with the OBS software or other video recording software.
Yes, Laoshi.
OBS. you can use the OBS is software to record use a segment simulation. You can go to the internet, the web to download and install the OBS.
Laushi, maybe the class time is over. We can finish it now for today.
What? I didn't hear you.
Laushi, maybe we can finish the class for today.
Oh, okay.
Once we are done with the homework, we will send it to the monitors and the monitors will send you.
Any
Laushi, could you
students,
please?
any student complete the segment?
Hello, Laushi.
Are you complete the segment?
Laushi, could you please send me the PPT on WeChat?
Mm-hmm. If anyone completed the segments, maybe
Yes,
you
Laushi, almost. Danisha.
can share your screen and show all your simulation results.
Okay, Laushi, 1 minute, please.
Any students want to share your screen?
Yes, Laushi, I want to share. Just 1 minute, Laushi, please.
Okay. Okay.
Laushi, can you see?
Okay. Let me.
Is it working, Laushi?
Wait a minute. Let me check it out.
Oh, I made a mistake.
Missed push button.
Yeah, I have to make it read, right? And then this button.
No. Push button.
Oh, yeah. Here, right? East. Now it's okay, Laushi.
You try to set the black lights at just a second. Change
Which
the
one?
black lights.
This line?
Change the black lights. Code.
Code.
Code. Code.
And then
Choose the code.
which one, Laushi? I have to select.
You can use the drop down menu to change the code model. Blocks. Choose the
Yeah.
text. Yeah, continue.
And then
Yeah, change the delay time.
delay time. It's 50, right?
$500.
And then
No. Oh,
The second one, delay time, it's also 150.
delay time.
yeah. Then click start simulation.
We don't need to change here and here.
You set
It's
the
just
break
for
rate at 20 and 15 milliseconds.
Okay,
You
then you
click
start simulation, right?
Yeah.
Why it's not going? Laushi, we can show it later, next class. Today's time over.
You change the delay time to 500.
500, okay.
First, stop simulation. Stop simulation. Listen. Yeah.
500, right?
Yeah. Then click start simulation. Yeah, you can add the lights, the L, in the Arduino. In the Arduino, the L,
Here?
the break rate is changed. You can
Hello,
change. Okay. Let's.
hello. Laushi, can you hear me? Hello,
Hello?
Laushi, can you hear me? Laushi, can you send us the PPTX on WeChat?
Okay.
Okay, thank you.
Laushi, what should I do now? Maybe we can show it next class, Laushi.
Okay.
All right.
Next week we'll show it to you.
All right, Laushi. Thank you.
What's your name? Let me take your name and student ID.
This is my
C-
name and the student ID.
003 CH. Okay. Good. Good job. 谢之美。Any students and other students to share your simulation. And other students, remember the segments have two parts. First part is simulation, and the second part is use documentation to track the project you have completed. For each project, at the rest keep the records of the circuit code and use comments. Any other student finish the simulation? You will share your simulation recording.
Oh, I think this is our first class, so we are not ready yet. We will show you it in next class.
Laoshi, maybe from next class we will be ready.
Hard. So Laoshi, you want us to show you in every class or after class? Laoshi, anything that
Okay. Okay. Next week before the Wednesday. Okay. Finish the segments.
Okay, Laoshi.
Okay, Laoshi.
So Laoshi, you want us to show in every class or after the class? Laoshi? Laoshi, you hearing me?
Maybe you will show you the simulation segments through the screen sharing and give some comments in the next class.
Oh.
Okay.
Okay, Laushi.
You can see each segments show others that each project is completed through screen sharing and giving some comments for
Oh, okay.
percents.
Alright.
Next class, okay. Next class.
All right. Oh, Laushi, I would like to show you now. Can I? 而且没有时间了。Oh. You have to turn off your screen sharing.
Okay. About the screen sharing and give some comments. Maybe it's all of use. Maybe I choose some of students. Okay, in the next class.
Yeah.
Okay,
Alright.
Laushi.
Okay. Okay. The class monitor needs to send me the students' attendance and segment before every Wednesday. Okay.
Okay, Laushi.
Okay. Class over. See you later.
All right.
Okay, see you, Laushi.
Any question can ask me by the WeChat. Okay.
Yep.
Laushi, please send the PPT in the WeChat group.
Okay, class over. See you later. Bye.
Bye-bye.
Bye, Laushi. Have a good
Bye.
one. Have a good one.
Bye-bye, Laushi.
Bye.
Bye, Laushi.